Alright, so in this video, we're looking at subspaces again, but now we want to show that something is not a subspace. So remember, to be a subspace, you have to be closed under both the vector sum and the scalar multiplication. So showing that either one of those things fails is enough to show that it's not a subspace of R squared. In this example, where if U is all vectors xy such that x cubed plus 7y is equal to 0, I'm going to show that both of these things fail. Now remember, for your purposes, if you want to show something's not a subspace, you only need to show one, but it's good to have practiced showing that either one or the other in fact does fail. So the first thing we're going to address is closure of the vector sum. Right. What you want to show is that it's possible to take two things that live in U and sum them together so that the resulting thing that you get doesn't in fact live in U. And so if we take a look at what happens when we sum together two things, we first got to pick two elements of U. So let x1, y1, x2, y2 be in U. In other words, what that means is that x1 cubed plus 7y1 is 0, and x1 cubed plus 7y2 is also 0. And so the question is, we claim x1 y1 plus x2 y2 equals x1 plus x2 y1 plus y2 is not in U, right? That's our supposition, that this thing we wrote out here is not in general an element of U. Now remember, of course, you can always find an x1, y1, x2, y2, where that'll be true, just like let everybody be 0. But the point is that this isn't going to be true for every single possible x1, y1, x2, y2 that lives in U, that there are going to be some that don't satisfy this. Now, if I want to see that, what we note is so what I note is that if I take x1 plus x2 cubed and I add it to 7 times y1 plus y2, that should not in general be 0. And so if I work out what this actually is going to be, well, x1 plus x2 cubed is going to be x1 cubed plus 3x1 x2 plus, or x1 squared x2 plus 3x1 x2 squared plus x cubed, and then plus 7y1 plus 7y2. Now we note that there is some cancellation that's possible here. I do have an x1 cubed and a 7y1. And remember what we established was that x1 cubed plus 7y1, that's 0. Then, lurking about over here, I have a, sorry, there should be a 2 here, x2 cubed and a 7y squared, and that's also 0, right? Again, because of this fact here, right? So I can go ahead and circle that. But I still have, so all of that's 0, but I'm still somehow left with 3x1 squared x2 and 3x1 x2 squared. And as long as x1 and x2 aren't 0, this is not going to be, in general, equal to 0. So this vector fails for almost every possible choice of x1 and x2. Certainly I could find an x1 and x2 where that's going to fail. So U is not closed under sums, under vector sums. And that by itself is enough to show that it's not a vector space. Now, you don't have to go through all of this work as well. One thing you could also try is to see what happens to specific examples if you just found two, an x1, y1, and x2, y2 for which that live in U, but whose sum doesn't live in U, that will be good enough as well. So I think a good choice for x1, y1, and x2, y2 would be 1, -1/7, and 1, -1/7. Right? 1 cubed is 1, plus 7 times -1/7 is 0. So this lives in U. And this is the exact same vector, so that lives in U as well. But if I consider their sum is 2 minus 2/7. I won't go through all the detail, but you should be able to see that 2 cubed is 8, minus 2/7 times 7 is minus 2, 8 plus -2 is not 0, right? It's 6. So what we found, again, is two vectors that live in U, but whose sum does not live in U. And that shows that U is not in general closed under scalar or under vector addition. Now, the other approach is to tackle scalar multiplication. So, and to show it's not closed under scalar multiplication. And so once again, we claim xy is in U, i.e. x cubed plus 7y is 0. Or we let, this is a thing we assume, and our claim is that cxy is not in U in general, right? So how do we approach this? Well, what we note is that cxy is equal to cxcy. Right? And now if I take cx cubed plus 7cy, the question is that 0? And our claim is going to be not in general, right? That there's possible x's and y's for which that's going to fail. And so if I take a look at what that's going to be, this is going to be c cubed x cubed plus 7cy. Now, there is some potential for some cancellation. We could rewrite this whole mess as c cubed minus 1 x cubed plus 7c minus 1 y plus x cubed plus 7 c minus 1 in parentheses cubed plus 7y, which gives us c cubed minus 1 x cubed plus 7 c minus 1 y remaining. But there's very little chance that this is going to be 0 for all the possible xy pairs that live in U. So again, if we want to show this more concretely, we could let C be 2, X be and our vector xy is going to be 1, negative 1/7, as we've had before, and we're going to note that cxy, so this is xy, cxy is going to be 2 minus 2/7, and then 2 cubed plus minus 2/7 times 7 is going to be 8 minus 2, which is 6, which is not 0. Right? So what you can do in these cases is pick a specific vector or pair of vectors that shows that one of these two properties fell. In any case, U is not closed under scalar product, and U is not a subspace. Of R squared. All right. Thank you very much. I will see you in the next video.